support. If you look close, you can see that the tracks are even lifted off the ground there of that loader. Another great example of how it binds the soil together. We were working with the Navy to develop a rapid repair for bombed runways. In this project, they went out and bombed a runway. They immediately backfilled all the debris into the crater, and then we injected it. The runway was back in service in less than an hour, and afterwards they removed the mass to test it, and it was extracted as one large stabilized mass. Now we'll look at some of the different industry applications. Since many of our commercial customers who are on this call have unique sites, we'll breeze over some of our different industry applications. It is beyond the scope of this presentation to go into detail on each of the industries, and each of the industries have enough content to make up their own presentation and webinar, and we do have those for those industries. So if you want more details on any of these applications or industries, let's follow up after this webinar. So for typical foundation and slab lifting or stabilization of any type building or structure or pavement that's soil supported, we can do our URETEK method directly under the slab, provides a continuous blanket, spreads the load under the slabs, and then our deep injection is used more under foundations and footings to go to the weak areas of at depth. And these pictures, this treatment is a lot of what we'll be looking at when we get into the commercial section in just a minute. Common civil work applications are at dams, seawall sealing and stabilization, seepage mitigation, and earthen dam stabilization and cutoff. We've engineered special formulas of polymer specifically for runways and railroads that have significant dynamic and point loading, such as jumbo jets touching down or trains crossing. Roads, parking lots, driveways, bridge approach and departure slabs. This example is a little too interesting to not explain. This was a subdivision entrance, and the developer contractor had cut the ends off 2 railroad boxcars and used them for culverts and failed to seal or properly compact around them. We had 12 inches of settlement on each side of the 2 humps. And in 1993, we injected to stabilize the soils and lift the pavement back. This picture was taken in 2008, but it's still the same way today, exactly as we injected. We're able to provide injectable barriers or grout curtains for groundwater cutoff and contamination containment. We recently conducted a webinar on this application that is available if you're interested in watching it. Port facilities, we can be used on the tarmac and intermodal side, and then also on the seawall side as well. You can see the material outcropping from where it was sealing and filling voids behind that seawall, sheet piled wall. We can do this since the material is hydro insensitive and environmentally inert. Almost all facilities have underground utilities. We do a lot of utility work for state DOT and municipalities, but also a significant amount of private utility work, whether it's maintenance issues or even during construction or shortly after on new construction. We're able to inject from the inside out in structures and in pipes that are big enough for us to get into, so that we can provide a positive side seal on the outside of the structure. And we can also inject from the surface down, which we'll see on the next slide. This is another good illustration of how the product works, because a lot of what we do and install, you don't ever see it. So this is around pipes and manholes. We are most commonly used with storm drain or larger diameter pipe that we can get into, and whether we're injecting inside or just monitoring from the inside. Some of the common problems are sheared lateral pipes, faulted joints or junctions, weak soils at the surface, around the structure, and then also beneath the structure. Our strategic injection pattern is designed to address all the problem zones, sealing the lateral pipe and lifting it if necessary, void fill, stabilize, and densify soils beneath and beside the structures, and then also void fill, densify, and lift at the surface if needed. We've recently added a new product line to our services. It's called APM Permaform. It's a spun-cast technology to renew the inside of manholes and pipes. It is a structural application that restores the strength of the pipe. Often we need URETEK to treat the outside and then a liner to treat the inside. We're now able to provide more of a turnkey solution when that's needed. We also have an entire webinar presentation on this application for the outside and inside of pipes if you're interested in that. So last but certainly not least, it's the reason we've all gathered here today. It's for commercial buildings and facilities. We'll start this section with a couple of short videos to illustrate the process, and then we'll skim through some case studies. We have a varied audience of commercial real estate owners, property managers, retail, tenants, warehouse, industrial, and manufacturing engineers and contractors. So I'll speak more to the cause of the problem and the solution rather than going into the details of the project itself. And this presentation will be available afterwards, so you can come back and look at the details of the projects if you want to see those details. The audio for these videos may not come through, and then depending on the connection, your internet connection, the video may be a little grainy or choppy. Just bear with it. I'll point out some highlights as they play, and we'll provide links to the videos so you can stream with full video and audio afterwards. This video is highlighting an interior slab lift. The slab had settled and pulled away from the walls. There was some also highly sensitive precision equipment that was experiencing vibration. We were able to lift the slabs, fill the voids under the equipment, and eliminate the vibrations. I should probably also point out, you'll see later in this video, sometimes we're able and certainly willing to pull up the carpet as it shows in the video. But I do want to throw in a little disclaimer that there is some risk with that. Sometimes the carpet's glued down so well it has to be professionally demoed or removed, or when we cut it, it is damaged beyond repair. But there are risks with leaving carpet or any floor covering down, and that's that we can't observe the slab joint locations, and if there are any cracks in the slab. If cracks are present, we need to space out our injection points accordingly and be able to monitor the cracks as we inject. When there are floor coverings, we may not know until the material outcrops and bubbles up beneath the floor coverings or even expands the cracks more. So it's ideal to have an exposed slab, and we'll walk through these risks on every project. You know, again, all the projects are unique and conditions are site specific. So that was a quick overview of what to expect with the trucks pulling up on site, running the hose into the building, and then pulling off site. This is a quick time-lapse video showing a warehouse floor lift. It's a 10-inch slab, or a 10-inch lift, about a 12-inch slab, and what equated to an approximate 100-ton lift. The work was completed after hours. There was no downtime for the warehouse. All right, now we've arrived at the case studies. And this is an equipment stabilization and lifting application. And this project's a great example of significant load in a relatively small footprint. The aluminum coil turnstiles would lift to one side when it turned or when it was unevenly loaded. URETEK stabilized the weak soil and lifted under the sleeper slab under full live load conditions that exceeded 250,000 pounds, and we were able to lift it back to its original elevation. We're often able to help when existing spaces are being repurposed. Here we increased bearing capacity for increased column loads where a new mezzanine level or penthouse was being added. It prevented the customer from having to saw cut and remove slab to install new footings or deep foundation systems. On this high-rise residential and retail building, voids were discovered underneath the building while the owners were attempting to refinance the property. Excuse me. The lender required the voids to be filled under the footings, and they wanted a lightweight solution that could be installed despite the confined space and poor access on this site. Here we provided 8 inches of lift in this Minneapolis manufacturing facility to restore their rail and conveyor system, keep operations up and running. Parking lots and sidewalks, most of the problems were called into at parking lots are to seal storm drains, pipes, manholes, or joints and stabilize the soil. One of the first challenges we have is identifying the problems in an early stage before it becomes an emergency situation. Then the second challenge is getting funds allocated for what's often viewed as preventative maintenance before it becomes a large sinkhole, collapses, and then it's an emergency situation and a bigger problem. With sidewalk trip hazards, if it's one sidewalk panel, we may not be the most economical choice. If there's decent scope and size, we may be a good option. We're always happy to price it and give you budgets just to see what your best option is. Here you can see the settled slabs with heavy pooling of water. It definitely becomes a dangerous hazard in the winter when it freezes. The faulted joints also allow water to go under the slab, accelerating the settlement and damaging and eventually ruining the slabs. We were able to lift and underseal the slabs. You can see the subgrade water being displaced through our relief holes that our material is pushing out. There was no downtime for the client, and they could drive on this area by the time we were demobilized. This is some inline retail space that had organic soils below the building. The load-bearing structure was pile supported, but the slab had experienced settlement and voids beneath it. We were able to lift the slabs and some areas in the parking lot, fill the voids, and also seal an abandoned utility pipe during off-peak or closed hours so that there was no lost time for the tenants. Similar type project, parking lot and entry slabs had huge voids between them and up to 7.5 inches of settlement. We were able to perform the work at night to avoid disruption to business. After 4 night shifts, 13 slabs were lifted back to within 1/8 of an inch of original grade. This is a good time to stop and sort of point out and explain how our material is calculated and priced. It's all by volume and density of our material, which really equates to the pound of material required for a project. So on this project, we had 12-inch thick slabs, 7 inches of lift, plus voids beneath the slabs. So you have the weight of the slab, the amount of the lift, and the amount of the void that goes into it. If the amount of void or lift were 1 inch, you could do for a fraction of the cost, or 8 or 10 times the area of treatment. Under the same settlement and void conditions, but with a 4 or 6 inch slab, it may have taken half the material or even less, or we may have been able to do 2 or more times the amount of area. Because with the load, how that comes into play, whether it's a 6 inch or 12 inch slab, and if there's equipment on top, it requires a higher in-place density of our material to have the strength to lift it. So all of our calculations are based on pounds of material needed. Square footage rates are not the best unit of measurement. Again, we perform night work to lift and stabilize soils at the cash wrap area with no downtime to the client. The geotech report discovered trash and debris trash or debris pits at about -8 feet down to about -16 feet, and that had caused cracking in the slab and settlement. We treated the slab and voids at the surface and then stabilized the debris trouble with that word, debris pits at depth. All of that was completed with only the invasiveness that you see here in the pictures, 5/8 inch holes. The exceptions to our hole width is if the project requires that we're going to multiple depths or elevations of stabilization in the soil, and we may need 4 or 5 injection tubes at each location. Sometimes one core drilled hole per location may be more desirable than 3 or 4 or 5 small holes. And we discuss that with the client on a per project basis. This was an office building completed we performed our scope of work just 2 weeks ago. CBRE was very happy with the results. Again, it was an occupied space with minimal disruption. We did a slab lift to repair a recurring problem. The previous repairs had included an expensive floor leveling with poor, long-lasting results. It was really putting a Band-Aid on the symptom and had no long-term effects. And it was also causing continued inconvenience for the tenants. This project, we were brought in by the geotech engineer to stabilize soils beneath the building. Here we lifted the slabs up to 2 inches in an office and warehouse flex space to avoid the slab being ripped out and replaced. We were able to provide some value engineering on this project to reduce the repair cost by 70%. More night work at this project. This time it was a doctor's office and to lift slabs to make the equipment, doors, and furnishings all operable again. Another flex space project had experienced settling footing, 8-inch voids beneath the slabs. The VCT flooring had popped up, creating trip hazards, and the ceiling grid had buckled, causing ceiling tile to fall out. We stabilized the footings, walls, and the slabs, and filled the voids so that cosmetic repairs could last. Often the cosmetic repairs are made before the soil and slabs are stabilized, and as most of you probably know, it's just a continuous recurring problem. Similar here, lifted the slab and the walls to eliminate tripping hazards and to allow the cosmetic repairs that would last. Slab settlement in occupied space. Sounds familiar. We did perform the work on a Saturday to allow the door frames to re-engage to the ceiling without any disruption to the tenants. This was a newly constructed facility that had experienced severe soil consolidation, varying problems, building foundations, slabs, even at the rail spur that comes on site. We were able to stabilize and lift with no disruption, actually stabilize the rail bed while the train was being loaded. Again, the most important value here was zero facility downtime, and we're actually finding out today about the next phase at this site. This is the last case study we'll look at today. Most of you may not deal with military or commercial airport operations, but this project's a good example of how deeper problems cause problems at the surface. And the good thing about this project, we have verified long-term results. Almost all the factors involved on this project are found on almost every site, no matter what the use is. And again, the most important factor here is that we were able to investigate 11 years after we did the installation. So the runway here had settled and had a dip in it 11 years before the scheduled runway replacement time. The cause of the settlement was faulted joints in the 60-inch RCP storm drain beneath the runway. Obviously, the Air Force didn't want to rip out and replace due to downtime and to budget. So we went in, sealed the pipe, densified and compacted the soils between the pipe and the runway, and then lifted the slabs back to the original elevation. It extended the life of the runway until its scheduled replacement time 11 years later. At that time, the Air Force called us to see if we wanted to come out to investigate the excavated materials. One of our engineers went out to observe. They found that there had been no signs of shrinkage, cracking, or deterioration of the material. It looked, felt, and even smelled just like new material. So that concludes the look at different applications and case studies. As I mentioned earlier, that the intent wasn't to belabor the project details, but more to show the cause, solution, and application so we can help you or your clients be aware of all options and hopefully save some time and money. If you want specific information regarding any of the other projects or applications, please let us know. And now we will look at what we need in order to be able to help you and what to expect from us when you have an opportunity for us to provide a solution. What we'll want from you is basically as much information as you can provide. We're going to ask for a description of the problem, your desired solution, the history, pictures, drawings, specs, engineers' reports, soil reports, void surveys, etc. Whether it's from original construction or current, or even better, if it's from both, so we can see the trend over time. Our intent is just to gather as much information as possible for every project. We understand that all of this info isn't always available, and often almost no information is available. We're just doing our due diligence and gathering as much information as we can. And what you can expect from us is that we'll conduct a site visit, ask questions to fill in missing pieces of information so we can provide the best solution. And if we don't feel like we're going to be a good solution for the project, we'll certainly point you in the right direction if we can. Depending on the site conditions and information we gathered from all the items above, we will either have enough information to prepare a proposal and a design, or we'll need to request additional information. sometimes there may be a lot of info but not enough relevant information, so we'll recommend you hire a consulting engineer to investigate the site or structure. Sometimes you may only have little or zero information, and it may suffice. Each project's different, and we analyze all available information in site, scope, and risk to make the recommendation to you. And when we finally have enough information, we will provide a detailed proposal and perform the work with our permanent crews. That wraps up the content of the presentation. Just a few closing comments before we open it up to questions. And sorry, I got in a zone. I haven't even looked over there for any hands raised. But we're close, so just sit on your questions for just another second. We invite you to connect to us on all the social media just to stay current with our relevant applications, notable new projects, and any other news. And I'll just close by saying that we have successful completion of tens of thousands of projects of jobs on commercial buildings, interior and exterior, whether it's foundation stabilization, slab lifting, or infrastructure with minimal interruption. 5/8" holes, no mess, and we're usually in and out in the same day. Of course, that depends on the project size. We have technical product data and third-party test results on all the materials. Our engineers have prepared white papers on each process. We can assist in writing and providing specs for specific projects. We're also happy and eager to come perform brown bag lunch and learn presentations for you and any of your clients. So just please let us know anytime you have an opportunity for us to provide a solution. Just want to thank you all for your time, and now we'll open it up to questions, and Robert Armstead may be chiming back in here to help facilitate that.
Absolutely. Okay, so the first question is, can you give any PSF figures on, or that may meant to be PSI, for example, what mass excavated from the Air Force runway tested at?
On that particular project, we do have a report, and I don't know if there were any PSF numbers extrapolated from that. I know just our material itself, the minimum compressive strength is 8,640 PSF or above. And so whoever's asked that question, when you get the follow-up email, if you'll send that back to us, I can send you the report and some additional information. Just one comment on the strength of our material is that it's directly proportional to the density of our material. So if our material is a 4-pound free rise, like if we're just squirting it out on the floor, it would be 4 pounds per cubic foot free rise. If we're injecting, anytime we're injecting under a slab or into the soil, there will be resistance. And anytime there's resistance, there will be increased in-place density. So our in-place density of material may be 4.5 pounds per cubic foot on a void fill application. But if we're lifting a 12-inch slab, it may be 10 or 12 pounds per cubic foot. And then if you add other load factors, the in-place density will go up. But one benefit, the main benefit of that, is that our strengths go up exponentially from there. And we also have third-party test results that show some of those correlations. So we'd be glad to provide that afterwards. Good question. Any other,
sure, no, there's
questions, Robert? My screen's not showing them.
Oh, there's quite a few. So we have one.
Okay.
Don't you have to assure the erosion mechanisms cause of soil loss is controlled? Otherwise, you'll be injecting over a very long time.
so I'm not sure if I understood that exactly right, but if there is another external factor causing soil erosion or surface erosion, that would need to be addressed separately. One thing we are not is we're not a surface treatment, because UV actually is one of the biggest attackers of our material. But if the question was geared more towards if we continue to inject our material, are we going to lose it in another conduit, or if it's going like in a void within soil, our injection grid and layout is designed on average about 4 feet on center, both horizontally and vertically. That can vary depending on site characteristics. But for stabilization and void fill, that's about what it is. And we design it that way so that we're controlling where the material goes. We're only wanting to treat a small area at one time and then move to the next point so that we don't encounter that loss of material. Because if we continue to inject, the material is just going to continue to flow. So we'll take short shots and pause to give the material time to set up and contain itself in the areas we're intending it to stay. I hope that answered that question. If not, please submit a follow-up.
Okay.
Good question, though.
Next question, is there any concern about hydraulic pressure during injection displacing subsurface lateral pipes, roof drains, for example?
No, and that is, well, we take that into consideration and prepare our design accordingly. If you pumped enough oatmeal in there, there would be concerns about lateral and vertical pressure. But our material characteristics are going to follow the path of least resistance. We'll know about how much to put at each point. And if there are lateral concerns, like if oftentimes when we're void filling or stabilizing behind retaining walls, we have a different formulas of material, and this was going back to the material characteristics that have different expansion properties. So some expand more on the vertical plane than more on a spherical plane, and so we take all of those factors into consideration when we're picking the material to use and designing the repair for the project. But under normal conditions, there's no risk of collapsing an adjacent or even displacing utility pipes or any other structures. A good portion of our work is actually force sealing those pipes, and you're going to have material outcrop at the surface long before there's enough lateral pressure exerted to damage any adjacent structures. Next.
Is the product easy to break up, excavate, or trim?
Yes, it can be, and some of that, it's always able to be removed. How difficult or how much, I guess, equipment is needed are a couple of things. If it's within the first 24 hours, you may be able to do it by hand. A lot of times, and if you've seen any of our other videos that show material outcropping or pictures that show it coming through cracks, we can just break those off by hand. If it's like under a slab or a building and you're going to be doing construction later on, then it would be, after it's fully cured, it would probably need to be removed just like you were doing concrete. You may be able to pull it out by hand tools or saw it out, but it would probably need to be saw cut and moved out just like any construction material. One of the reasons for that is that the density and the weight of the material is still relatively light, but it's likely, unless it was just used for strictly a void fill, it's infiltrated into subbase, it's bonded to the slab or the structure, and it's also infiltrated into the soil matrix, so that a lot of the weight, the in-place weight, is the weight of the actual aggregate or the soil itself that it's infiltrated into. But it can always be removed with normal construction equipment.
There was a follow-up to the erosion question, and the clarification was that there may be a regional reason why soil is eroding, and if that reason is not addressed, you will need to be coming back until a large area is foam. So basically, we would have to inject into a larger area, as opposed to correcting the regional problem and only injecting a lesser amount of foam.
Sure. Okay. Then we would, still not sure exactly what that means. So I'd love to talk about that in detail, maybe offline, and we could issue a paper on it if it's once we understand all the facts. But if we saw a need, and if that is basically saying that there's other factors, or then we may either not look at the project until the whole region can be treated, or there would be qualifications on the treatment. And if we saw any risk or hazards, we would definitely make the client or the appropriate parties aware of it.
And I think that addresses it, David. I think it was more or less pointing to the factor of ensuring that you're stabilizing what the cause of the soil loss is prior to injection in order to have the best utilization of the foam.
Okay. Thanks.
Can you discuss URETEK's application for environmental remediation projects?
Yes, I can, but that in itself will be, to really go into the full details, is a full webinar or a full presentation. We'd be happy to do that. It would probably be better served to do it offline, but typically we're used to isolate whether groundwater movement, contamination flowing through the soils, or to provide sort of a vertical barrier around environmental areas or contaminated areas. But we'd be happy to go into full details on that, either in another presentation or get you we completed an injectable barrier webinar that was geared more towards environmental a few weeks ago, and can definitely get that to you.
Okay, the next question is there a limit to the depth of injection?
There is really. We've never had the need to go much deeper than around 50 feet, and we can go that deep vertically. But typically, one of the main tenets and benefits of the deep injection process is that we can achieve relatively shallow, you know, up in the top 15 to 20 feet of soils, what traditional methods or other deep foundation technologies have to go to refusal or down to bedrock or deep soils for. So even though we've only gone, most of our deep injection soil stabilizations are around 15 to 20 feet, in the upper 15 to 20 feet of soil. We can have shot horizontally, like on fill in abandoned pipes or slip line pipes, annular void space, around 100 feet horizontally. Some of the factors on what our limitations are is the cure time of the material. It'll begin to set up and cure before it gets out of the pipe. We do have some ways to manipulate that, and we just never really had the need to go much further. So typically into the soil, we're usually within that top 30 feet, but can go down to about 50. And happy to look at anything that would require us to go any deeper. Good question.
Okay, the next question is, have you used this material to stabilize soils around wood utility poles?
Yes. Yeah, we've done it. Typically power poles, some street traffic signalization type poles, but yes.
Can you explain the difference of the material for structural support versus material for sealing trench against water intrusion?
There's not much material difference. The difference is all in the chemistry, the hydroinsensitivity, which way it's going to expand, the density of the material, how far it's going to travel. But it's basically the same material, just different formulas. And the installation procedure is actually identical. We would either be injecting directly through the slab or structure or pipe, and if we were lifting a slab, we would just be injecting right under the slab. If we're sealing a concrete box culvert, we're going to drill right through the floor and just inject directly under it. So there's not a whole lot of big differences in the type of material. It just has a few different factors or formulas that are better suited for the application.
Okay, next question. It seems that the product is better suited for voids or open graded granular soils rather than soft and weak clays due to the process of expansion into voids. Can you comment, and have you had success in improving deep soft clays?
Well, that's a question we get a lot, is about the clays. And on clays, you're not going to get the infiltration that you do on an open graded granular soil or in voids, or really the encapsulation of the particles. What you're going to get is, and this goes back to our injection grid and layout, is the improved the displacement from the material as it expands, and the interaction between the injection points. So you're really more reliant on the bridging and stabilized overall mass rather than the actual improved or encapsulation and locking the soils together. But then the last part of that question kind of goes back to one of the previous questions about depth. I'm not sure what deep soft clays are. So it would just be site specific on how deep and how soft the clays are, how wet, and the elasticity of them. But yes, we can treat them, and a lot of times in expansive clays, we're even used to do sort of an injectable barrier to stop the moisture fluctuations and have it be more of a uniform moisture level. So that's getting into pretty complex soil mechanics as it relates to our product, but yes, we can be a part of it. Very site specific.
Okay, the next question. Would this material be affected by petroleum spills? And I'm going to assume in that meaning by saturation of petroleum
Sure.
products.
Well, I'll address two sides of that. One is if we were already installed or had a cured product installed and then had a petroleum spill, no, it wouldn't be. Our product has been designed to withstand any sort of normal oil-based petroleum gas, oil, diesel, kerosene type products, and it does well, especially with the products we have today. A lot of times we are used for sort of that barrier application, cutoff application, to stop most of the uses, if not all, for our injectable barrier applications have been in petroleum contaminated sites at old gas stations or active gas stations or underground storage tanks that may be leaching into the soil, and then if a trench cut has taken place for utility work, it could have a hydraulic pull of those soils off-site, and so we've been used as a barrier to cut that off, and there's no impact on our material. The one exception with petroleum, just sort of a disclaimer, that we've actually engineered a new product for this, but it may be site-specific too, are on old sites, about 100 years old, where a lot of the I can't think of the word. I'm wanting to say surfactants, but I don't think that's right. A lot of the chemicals that used to be in fuels are not in them today. So we've had to engineer new products to stand up to a lot of the contaminants that were in soils or were put in soils 50, 100 years ago. But so far we've been able to address those as well. Okay. Next.
Okay.
Good question.
Are there any concerns regarding the temperature at time of application and injection of stabilization material? For example, restrictions when dealing with temperatures that are too cold or too hot?
Really the only limitation or factor is if you really don't want to inject into frozen soil because when it thaws, it's going to move, and so it's better to inject into thawed soil. That's not to say some applications there have been emergency repairs needed, and we've gone and injected right into frozen soil, got them through the winter, and with the risk that we had to come back, but we've actually not had to go back there. As far as ambient air temperature, no. Our tanks that hold our material are heated, our lines are heated, and so we actually control the temperature of the material, and that's one of the ways we can control the reaction curve of the material. So normal conditions here on Earth, no, there may be some winter conditions or protection that may be required, but no real limitations to it. And we're even used to mitigate frost heave. That was actually as I mentioned, URETEK's from Finland. That's how it was used over there for some frost heave mitigation, and is starting to be used here for the same thing. Good questions.
Okay, I have a couple of hands raised. I know that they had asked previous questions, but I want to give a second. If you have your hand raised in there and want to speak, please leave your hand raised. If not, please lower your hand, and I'll give you a moment to make that selection. One question we had come in was, is this a patented process?
Sure. Okay, and I can see the questions now. It all was at one point. Most of the time, or some of the patents have expired. The only thing that is still patented is the deep injection process. So the URETEK method where you're just going underneath the slab, the patent expired in 2003. And the deep injection process where you're going into the soil with injection tubes is patented.
Okay, I'm going to attempt to unmute Raymond Volpe. Let me unmute here. Mr. Volpe, are you there?
Yes, can you hear me?
Yes, I can.
Okay, you answered my question, so I just didn't know how to unraise my hand.
Oh, okay, certainly.
Okay, great.
Right. Thank you, Mr. Volpe.
Yeah.
And Mr. Al Perry, I have you unmuted. Mr. Perry? He also had a
Looks
question.
like one of the earlier questions was his, so maybe it got answered.
Correct. Okay, that's it for the questions for the moment. And
All right.
so I think we're good.
Well, thanks again to everybody that joined. We appreciate you taking the time. Hope it was beneficial, and please let us know anytime we can help you out. Did get one more question. Are we still on, Robert?
Yes, go ahead.
All right. It's what's considered deep injection. Deep injection, deep is sort of misleading, but or can be. It has no, it's not tied to any specific or minimum depth. It just strictly means that you're injecting into the soil with an injection tube. There's a few tenets of the actual patent, but effectively it's injecting into the foundation soil. So that could be if it's 1 or 2 feet deep, or whether it's 20 feet deep. But it's basically just injecting into the soil. And we can go into more details offline if you want to know the full tenets of the patent. Thanks. Good question. A lot of people do get misled or thrown off by what's deep. It's not really tied to any footage or depth.
Okay. I do want to make an administrative note, David. So after the close of this meeting, we'll be sending out an email to a form on the website. And if you're seeking for a PDH certificate, please follow this link. But we appreciate any feedback from all that are on the call to help us improve this webinar. So thank you very much.
Thanks, everybody.